Hello everyone, I am Sertaç Türkmen. I am going to present the study I have done in the graduation project, which is developing a face recognition system with attendance record. I hope you enjoy the presentation. I consider the presentation as three main parts. In part 1, I'm going to talk about face recognition to give a brief information to you. In part 2, there are steps to be told which are generally followed in a face recognition system. Lastly, in part 3, I'm going to mention the system with little details and show some examples of implementations. Face recognition process can shortly said to be utilizing the biometric data of the face and finding matches with another face to decide whether they belong to the same person or not. If you look around and search for it, you will see it's widely used in dozens of areas from smartphones to factories. Here you see the general steps to follow in building a face recognition system. I want to talk about them briefly in the next a few slides. To recognize a face, first step is to have it as a data. Therefore, we use a camera and software tools to detect and save it. Depending on the application, face image might need to be aligned in order to increase the level of correctness of the prediction. Having a standard in all data is useful in most cases. In the case of face recognition, having standard-sized images can matter. In order to make the machine understand the face image, there must be some feature points that describe the face. The feature data are used in the compare of faces to find if there is a match. In this project, Python language is used since it has a lot of tools for image processing and computer vision. It was considered an appropriate programming language for this project. As a compiler, Spider IDE is used. In order to create a graphical user interface, PyQt5 have been used, which is a Python library that allows programmers to make user interfaces for their programs. There are two datasets for training the model. One of them is for the model to use in training process and the other one is to be able to validate itself. Therefore, there has been created a training dataset and a testing dataset. For the training dataset, 20 images are taken from each person, and for the testing dataset, there are 4 images. In the project, since the aim is to have an attendance list, real-time detection is necessary. Here, the help of our Cascade module of OpenCV library is used in Python. This module is used since it is the most appropriate one for this study when considering the speed and ease of use. To create a model which has an ability to recognize faces, Keras library has been used which can be added to the programming environment of Python. In the model creating process, different values for the parameters have been tried such as input size, batch size, number of epochs, steps per epoch, etc. The final values of the model are seen below. It has an input layer which takes inputs of the size 64 by 64 by 3, 2 convolution layers, 2 max pooling layers, 2 dense layers, 1 flattening layer, and an output layer which has the number of neurons same as the number of individuals in the dataset. The model was trained with 648 images belonging to 67 individuals. Since the dataset is not a big one, the learning process of the model reaches its final and the best result in a short moment, like a few minutes, which is in this case a 99% accuracy as seen. After the training process is finished, the below graphs were created to see the relation between loss versus number of epochs and accuracy versus number of epochs. In the below figures, it seems that choosing number of epochs as 30 is appropriate for this model. If the model keeps training after this point, an undesired situation will be occurred, and since then the loss will be increasing, which affects the correctness of the model after all. For the ease of use and for the project to be good looking at all, having a GUI was important. To make the GUI have a modern looking, flat colors and a dark theme have been chosen. In the below figure, loading screen of the application can be seen. On the application, there are 5 pages named as Home, Recognition, Registration, Attendance List, and Help. This application can be easily used through these page buttons, and the user can easily navigate between pages. Homepage and help page are seen below. The dataset contains images of 67 individuals, including me. To add new faces to the dataset, there has been created a script to generate dataset, and the function of it is reachable from the buttons of the GUI. So, one can add new faces to the dataset from the application. In order to do that, one should click on the registration page and then click on Camera On button to see himself or herself before capturing any images. Then for the train and test datasets, there are two separate buttons. One for capturing 20 images and sending to train dataset folder, and the other for capturing 4 images and sending to test dataset folder. Here, faces are automatically detected after clicking the buttons to take photographs, and the captured images are cropped with respect to face coordinates. Therefore, the dataset has clear face images after this process. The next step after creating the dataset with involving new faces to it is training the model over these faces, including new ones. On the figure below, the buttons are seen, and at the very right there is Train the Model button. After clicking on this button, it will take about 1 to 5 minutes approximately to train the model, and then the new model will be saved to the folder of the GUI with the name model_new. After this is done, one can start to use the application to have attendances recorded on a list. When everything is set, we can go to recognition page to start taking attendance. On this page, again, one can click on Camera On button to see himself or herself before capturing any images. Then, when we click on Take a Photo for Attendance button, an image will be captured and cropped in order to make the model work on it properly. The captured and cropped image will be appeared on the screen for a while, and then the CNN model will return the prediction result as a name on the below text area. Then, when manual control is enabled, whenever the pink colored tick button is clicked, that means the name is correct and it will be saved to the attendance list. If the mentioned checkbox is not enabled, the name is going to be saved to the attendance list automatically when it's recognized without the need of clicking the tick button. The attendance list can be reached and checked via the attendance page of the GUI. After every time a person is recognized and his or her name is recorded to the attendance list, the list in the GUI is updated and is always checkable right away. The system can be said to be successful when considering the dataset size and the number of images belonging to each individuals in the dataset. The dataset is kept considerably in small size since the system represents a face recognition system for the aim of taking attendance and keeping the record of the related names. It can be used in places such as classrooms, conference halls, event entries, and so on. The model accuracy reaches up to 99% after the training. Although this is a high accuracy rate, during the prediction of names, the system can be affected by many different condition changes. The light conditions, the distance from the face to the camera, the position of the head in both X and Y axis, and the expressions of the face at the moment of taking a picture before the prediction phase are just a few of the mentioned condition changes. Now I want to show the real-time implementation of the system by opening the application. Okay, now the application is opening. This is the first page when we open the application that we see. This is welcome page. And here's a toggle menu. There are 5 pages. I'm not going to show all details since I have presented in them. And now I want to show how to create datasets for both training and testing folders. Turning on the camera right now. Okay, now I'm going to enter my name here, and now I clicked on this button and there will be 20 pictures that will be taken of me. Okay, now the pictures are ready for the training set. We can see them on here. Yeah, there are 20 pictures of me. And now let's do the same thing for the test set. Okay, it's also done. And here you can see there are 4 pictures of me for test set. Now I'm not going to click on this button. This is train the model button, and after our dataset is ready, we can click on this button on this GUI and the model will be trained. And now I want to show you the recognition page. I'm turning on the camera again. And when I click on this button, there'll be a name written here, and this will be the prediction of our model. Let's see if it's correct or not. Okay, now I got my headphones back on my head. And then now this manual control checkbox is checked, and so there'll be no name written on here on the attendance list because I didn't yet confirm this name. And now when I click on this button, this name will be confirmed by me, by the user, and here you can see the name is in the list with its time on appearance and time of appearance and date of appearance. And so here there's another page which is help page. On this page it's set how to use this application, and it's really helpful. And I guess this is all about this application, and thank you for your attention and listening and watching me. Goodbye.